Hi everyone, it's Arthur again from LEGO Education, and let's continue with our project here. So, last two videos we talked about prototyping, so how to start a complex project like this, how we can focus on a small challenge. So we are using the arm prototype. After I moved to the leg, like the prototype with for the arm was really close to what we have today. The prototype for the leg was a dummy one, so it was just something like this. Okay, so doesn't refer anything here, but I can really fast see if things will work. After we talked about the different motors and movements that we have, I showed also again testing it with another motor. So having like an interface where I move and I use the system to move. I'm not moving by using my hands manually. Well, I was happy with the individual movements. I was happy with the scale of the robot. I can say in that situation, when we are building, like I changed the height of this of the pillar of the stand several times because I was not really happy with how long was the legs. So I was changing the length of it several times to really create a nice scale for the whole thing. And I can say that, and I said also that in the beginning I had like just one movement to turn the whole body, and when I add like this extra turning table here, I enlarged it a little bit the body, so I changed a little bit also the legs length. But okay, so we are ready to move to the next phase. This phase is quite important because we want to create a copy of this in a 3D environment. You can find different ways of doing this with the Lego bricks. I remember doing this a long time ago, not using the reference, but like measuring all the parts, but it takes a long time, and but it's one way of doing this. But because Lego is so popular, and we have several people from the community developing, modeling all the elements, and we have like Studio or Elles or different kind of softwares to build virtually. That I decided let's try that. So if you need to search more about Studio, just to go to, let's go for YouTube, and I'll just go to Google and you type Bricklink and Studio, and here you can download it. Okay, so you can download for different platforms, and it works pretty well. So you can you can document projects. So if you're just building something and you want to document it, you can easily use the Studio for that. Here is the software. You can organize in different ways. If you have two screens, you can also enlarge the windows. So I normally do this, so I have a lot of space. What happens that you have like the standard library with like all the elements, and also the elements that are not produced anymore. So you can find several. You can look also for sets. So like if you are building with NXT or RCX, or probably you can also do this. But in our case, we are using 4 different sets. I'm using Spike Prime, Spike Essential, Pre-Q Motion Prime, and Pre-Q Motion Essential. So I'm using all of them. And what happens that you can search for the palette from the set, but what happens that some of the elements are still not there as a standard thing. So we need to download it. And again, the community is really good. And if you are not part, you go to, you can do it on Facebook. So there is a Spike Prime community there, and we can talk with different members there. And there is one guy that is extremely active on this. So Philo, he produced several models for WRO, and he is really good on that and quite fast. And he has a website. So if we go to Philo home, in his webpage, so you can find several different resources for robots or NXT EV3 sensors, a lot of cool stuff. And he has like parts packs for studio. So when you go here, you can find the different packs. So he just released the one that is for Spike Essential. Down here we are going to find the Spike Prime. So that's, if you want to build with Spike Prime, Spike Essential, probably you need to download it first, and you have like the elements to build. I did it already. So when I come here, let me just look for my custom parts, and I have it here. So, well, but let's move to how we build, because let's have a look on the robot. The robot is not aligned with the grid. So you have some elements that are aligned, so we can just start to build, but several of them are not. Like the leg. The leg has several angles that will be really hard to match. And right now, we are not really moving anything on Studio. The Studio, we are just putting the elements together. So to do that, we need to divide what we are going to do. So Studio, we are going to build everything in a straight way. So like if I'm building the leg, I'm not going to build the leg like this. So probably I will build like this. I have the leg. So I can use straight angles to help me to do that. We are going to move this part back in the next software. So right now we want just to have the elements. So I divide the model in several parts. So like I have the leg, I will have like the full body with the stand. I will have, because I don't know if you can see, but what happens that the arm, the shoulder motor, it's in an angle also. So it will be a little bit tricky if we want to do everything already in Studio. Also the head. To build it, you just grab the elements and place here. I will open the file that I have. So it's opening, it's a lot of elements. I try in this version to add all of them. We have one colleague in the Lego education in China. So they use this file to build a sister for Elles. Let me see if I can move this down. So as I was explaining, first, I didn't build the whole thing. Let's see if I can go a little bit. So the first thing, I don't need to build both sides because it's symmetric. So let's just go with one leg. I will do it in the next software. So I have it here. So as you can see, everything in a straight angle. So 90 degrees, make it easier. We are going to connect it later. The same thing I did for the arm. So this motor here will be in a different angle. And but right now I'm happy of just connecting the elements, adding everything to the right place. Okay. I did the same thing here for the head, as you can see here. So here's one easy thing to understand. This Spike Essential motor will move this ball link here. It will be connected to this one here. But if I want to connect right now, I need to rotate this motor and find the right distance here. and I would just leave like that, because we are going to create a system that we call inverse kinematics. Inverse kinematics is it's a calculation that we use to move the end of a robot to a the end of like a structure where you have several levers. And because like our arm, if I want to find, and let's see if I want to if I want to grab this hub here, and imagine that my arm is the robot arm. If I need to find the angle of my shoulder, my elbow, my hand, I need to calculate all of them. It's going to be a little bit tricky to find. Maybe I will. It's much easier to say, go hand to this position, and the calculation will do it. The computer will do the calculation for me. So if I want my hand in here to grab the hub, it will calculate the position of all the other joints. And that's what we are going to do. So in the next software, we are going to create structures that we call bones, and they will have like this feature of inverse kinematics. I will just grab and it will calculate. And that's what we are going to do to grab all the position of the motors, because that's what we want. It's important to have in this file all the motors, because they will give the data that we want. And I will again come back to that. Remember when we use it, one motor to move another motor, right? I could have like a sensor moving a motor. I could have several things moving a motor like this. But imagine this situation. If I could have, instead of a sensor, data from somewhere, and it will update the position of each motor. So each motor will receive data from my software, from my digital twin, from my model. The computer will calculate several things for me. So like if I want to move the hand here and place it here, it will calculate the position of all the joints. And that's what we are looking for. So it's important to have like this model as I presented here. It's important to have everything in the right distance. And if it's in the right distance, I presume that when the computer makes the calculation, it will give the right rotation for each element. That's what we are going to do in the next video. We are going to create this joints, and we are going to create relations between elements. So I will say, if this is moving, the motor should be moving in that fraction, in that rate. And that's, we work for all the different parts. Yeah, it looks a little bit complicated. Yes, I know, and but I believe the next video will explain a little bit better, and we are going to be easily understand this process of collecting data that is in the computer and sending to Elles. See you there.